Hello and welcome everyone to our breakout session called Creating a Smart Connected Product, the intersection of AI and IoT. So I'd like to introduce to you our speaker today, Brent Leland. Brent is a former CIO of Trek Bicycle and previously served as the advisory board of Advancing AI Wisconsin. He is the founder of High G, a boutique consulting firm focused on innovation and technology-enabled growth strategies. Earlier in his career, Brent held various finance, supply chain, engineering, and IT roles for Spectrum Brands, formerly Rayovac, Hewlett-Packard, L'Oreal, and General Dynamics. And Brent holds an MBA from Stanford and a BS in aerospace engineering from the University of Florida. And another thing that Brent likes to do, he's an avid home brewer and serves on the advisory board for Insight Brewing in Minneapolis. So Brent's got that in his background as well. So with that, Brent, take it away.
All right, well, thanks, Steve. Thanks for having me here. This is pretty short, so we're going to go pretty fast. And but feel free to type in a question if you want as we go throughout. Steve will monitor those, and if there's something that he thinks makes sense to ask during the presentation, he'll bring it up. Otherwise, we'll try to have a couple minutes at the end. If not, we have two small breakout groups, one later this afternoon and then one tomorrow, and I'll talk about those at the end in case anybody wants to dig into some of this a bit further. So I started my career designing rocket trajectories. I worked on a mission to Saturn called Cassini for 2 years, and it launched in 1997. And as some of you may know, you can't just send a satellite straight to Saturn. You could, but it would take way too much fuel. So you end up doing several trips around the sun and doing flybys or gravity assists, they're sometimes called, around the various planets. And Cassini was what was called VEJA, or Venus, Earth, Jupiter Gravity Assist. And my job, I was responsible for the Earth to Venus portion of that trajectory. So the reason I call this early AI and IoT, think about this like the early precursor to an autonomous vehicle. We had to predict where it was going, and then during the launch, guide it to where it was going to be. And at the time, the computers were slow, the simulations ran for days, and it was just hard to do. And if you, a couple of years ago, as an aside, you'll see that interoffice memo. Some of you may remember interoffice memos. This was kind of the precursor to emails, and when they were on paper. And I kind of found that out, and I had written a program for quickly modeling these interplanetary trajectories, and I called it Homer because this was right when The Simpsons came out. It stood for Heliocentric Optimal Mission Evaluation Routine. And the way it works, it was for a defense contractor. You submit something for approval. I submitted it. It goes up and down the chain. It came back, said, "Hey, great program, Brent, change the name." So I sent another memo up saying basically, "Hey, it's Homer. He wrote the Iliad and the Odyssey. We're using programs by NASA called Midas and Moses." So they let it go through. But what they didn't know is inside there were subroutines called Bart and Lisa. So you do what you can do when you're an engineer. So fast forward to today. And if you're familiar with Elon Musk's SpaceX, I think it's just amazing what they're able to do there. Why is it amazing? First of all, back when the original space shuttle launched, it cost $85,000 per kilogram to put something into orbit. So with the new Falcon Heavy, his new heavy lift rockets, it's basically less than $1,000 per kilogram. And you say, well, why is that? Well, most launches prior to this, most of the equipment, the rocket ends up splashing into the ocean. So what he's been able to do is really turn these rockets into sophisticated flying robots. And, it's going to come back down to Earth 5,000 miles an hour, turn around, burn, and land on these autonomous drone ships or drone barges. So just landing that rocket itself saves 70% of the cost. And then they've also created this ship that'll go around and catch the nose cone fairing, which is about 10% of the cost. And the other thing he's doing that I think is very, very amazing is this Starlink. It's a Starlink system. So normal satellite broadband, if you have satellite internet, it sucks. it's 28,000 nautical miles up. Latency is very, very long, the delay. So what he's done, he's creating this constellation of satellites called Starlink, very near Earth orbit. And it's going to have, and it's already in beta, gaming quality internet, covering third world countries, covering backcountry things, covering the ocean, things you wouldn't normally have it. And my son and I were out right when the pandemic started. We were outside at night and we saw this. It looks like a stream of machine gun tracers. Turns out it was a SpaceX launch. He launches 60 of these at a time. And then over the next few days, they basically spread out into a circular orbit. So when I talk about disruptive technologies, the ones I think that are causing the most disruption, that are having the most impact right now are really three, advanced analytics, IoT, and then AI, more typically now machine learning. So that's where I'm going to focus a lot of this conversation today. So when we talk about artificial intelligence, I think many people still think about AI from the movies, the Terminator, Skynet, robo-apocalypse, human level intelligence. And that's, I think, what what they call artificial general intelligence, or AGI. And what we're really talking about nowadays is more called artificial narrow intelligence. It's taking machine learning, typically deep learning, and applying it to very narrowly defined use cases. And it's all around us. And some examples, I think people are aware of credit card fraud detection. I can point, credit card fraud detection, typing in dogs into Google Photos and a bunch of dogs show up, autonomous vehicles. A couple of less known ones might be things like Amelia. So Amelia is probably one of the widest used virtual agents or chatbots for IT services. And she can take call personifier, but she can take calls through phone, messaging, chat. Let's say you get locked out of your account and you need to set up a new user. If she can handle it, she'll take care of it. Otherwise, she'll write a ticket and hand it over to your next level tech support. Another example that's pretty interesting is the Lowe's robot. And so these have evolved over time, and they're still more in a beta stage. But let's say you walk into a Lowe's, you've got a plumbing fixture you're needing to replace. You hold it up to the camera. It uses computer vision to recognize it, compares it to images in the database, and says, oh, is this what you're looking for? And then it will lead you to it. When it's not interacting with the customer, they haven't set up to do kind of inventory, shelf scanning, merchandising. So when we talk about artificial intelligence, there's the framework I like to use to kind of say, because most people don't need to understand how it works. I think it's really the, how does it doing what humans could only do before? And I like to use Google Maps as an example. So we have sense and detect information. So think about Google Maps. It's listening to millions of phones. It's getting location, direction, speed, collecting all that information. And then it relates it to contextual knowledge. This contextual knowledge, in their case, is all the information that Google has collected from Google Earth and Google Maps, and probably information about each of us and what we're doing, what appointment we're going to, et cetera. It's then able to identify patterns. It's really good at understanding the normal. So it understands the normal flow of patterns, normal flow of traffic, and detects anomalies, connects slowdowns, et cetera. And then finally communicates and interacts. It alerts you, hey, here's an alternate route. There's a speed trap up ahead, et cetera. So now I'm going to talk about some of the fundamentals. I think these are the key fundamentals that every leader should understand, kind of as we go into this sort of world of disruptive technologies. And the first one, probably no surprise, is about data. And I like this framework where you look at internal, external. So internal data, this is the data inside the four walls of your company. External data, data outside. Structured data, data that's in a database, easily queryable. And unstructured data is everything else. And IBM estimates that 90% of the world's data was created in the last 2 years. And 90% of that data is unstructured. So most of my career, when you talk about analytics or BI, it's really internal structured data, stuff sitting in your financial system or your ERP system. And what you have now is the ability to add other information to that. So other internal structured data might be everything in your emails or call logs in your SharePoint site, things coming out of sensor data on the manufacturing line. You've got external structured data, which in many cases is a lot of demographics, might be housing starts, might be economic indicators, weather forecasts. And then unstructured data externally is everything else, everything on the World Wide Web. So what that gives you the ability to do, so if I'm a salesperson, I used to get a sales report by customer, and my job is to come up with a forecast for the next quarter. In order to do that, I pull in information that's all over this picture. What you can do now is you can run, create an algorithm, create a program that'll look at all that, identify correlations, and have a bot create that forecast. And in many cases, pull in information the human didn't even know was needed to make that forecast. Fundamental two is really analytics is the foundation of AI. And the big shift, and it's shifting very rapidly, is this ability to go from the descriptive, so what happened, to the predictive, what's going to happen, and then to the prescriptive, based on what's going to happen, what should we go do? And there's a lot of capabilities that are coming out with the ability to do that. And there's many companies that are still, they're sitting at the starting gate when it comes to data. And you can't go from zero to AI. You really need a foundation around it. So fundamental number three, the algorithm. And I would normally, if we were in an audience, ask, what is an algorithm? And I'll get a lot of different answers. It turns out most people don't really understand what an algorithm is when we talk about it from a machine learning or an AI perspective. So if you think about traditional programming, you have a human analyzes some data, figures out some rules, and then writes a program. And then that program, they run the data through it, you get results. So think about traditional virus detection, where we used to get those DAT files that had the virus signatures, and it would run every week, and we would basically identify viruses. So when we talk about an algorithm, and this is what you do when you're talking about machine learning or deep learning, it's really looking at, it's 180 degrees opposite. It's taking the data and the results. So think about millions of people tagging emails spam or junk in Gmail. It takes those results, runs a neural network around them, and creates an algorithm, kind of an auto-generated program that learns to identify spam. So you then run more data through it, identify spam, and it gets smarter because more people tag more spam, and it gets smarter as it's going. So that's really when we talk about an algorithm. It's like a self-generated program, and it can be simple. It can be as simple as kind of your high school algebra curve fitting, or complex like facial recognition. So fundamental four, this is where we start to get into IoT, connecting AI to the physical world. So I think by now most people understand what IoT is, Internet of Things. It's basically a device. It's connected to the internet, has a unique identifier that can send and receive information. It might be a thing. It might be a Fitbit. It might be your smartphone or a camera or a smart diaper. It could be sensors on a manufacturing line. But there's billions of them out there, and they're essentially increasing exponentially. So lots and lots of data and lots of opportunity coming in. And where it ties into AI, it's really think about it like your brain and your body. So as humans, we can sense information. We can see and hear and taste. And we take all this information in, and our brain kind of looks at that information and says, okay, let's understand it. Is there anything we now need to go do? And then we go do something. So that's essentially when you combine AI and IoT, you get that ability, kind of the sensors and actuators ability. And a lot of the measures you can get IoT, they're typical things like counting or temperature or position, velocity, but you can get into very much more complex things. Might be gas levels, acoustics, virus signatures, things like that. So if you remember back to the slide I showed, kind of showing some artificial narrow intelligence use cases. So each one of those has an IoT component. You know, an autonomous vehicle has a couple hundred sensors on it. Even that Roomba robot vacuum cleaner has a dozen sensors on it. So AI needs IoT, IoT needs AI. But what it gives you the opportunity to kind of create things you couldn't do before. So a couple examples. So Coke, if you think about the, you know, kind of the automated beverage dispensers you have in fast food chains and movie theaters, all that data goes back and they can analyze that. And Coke found that the most mixed flavor was Sprite with cherry syrup. So they launched Cherry Sprite. Another example, and this is where a lot of this more predictive machine learning is happening, is really in manufacturing and looking at predictive maintenance. So it's, instead of changing a belt at a certain amount of time or after it fails, it's understanding the, you know, the minute changes in vibrational data that will kind of be an early predictor of when a belt might fail, for instance. And then finally, it doesn't have to be IoT, where kind of these new possibilities come up. So if you think about manufacturers monitoring social networks to detect support issues. So I'm going to go through several trends, kind of how this starts to impact the business world. So the first one is everything is connected. So if you think about any sort of product company and service company for that matter, somebody has to design and engineer something, they make it, they build it, they sell it, it goes into use, and then they service and support it. And those historically have been silos. When I was at Trek Bikes, we sold through the independent dealer channel. We didn't have a connection to that end customer until, hey, 4 years later, my frame cracked. What do I do? So what you have the ability now with connectivity, whether it's IoT connectivity or whether it's connectivity through kind of the social internet world as well, is these feedback loops. And these feedback loops are feeding information all the way back through your value chain. You know, and it might be, one of my clients is they manufacture appliances. And they were able to take and shrink, when they first rolled out their connected appliance, they were able to shrink the 6-month field test to 3 months. Instead of sending out surveys and collecting information, they get real-time compressor cycle information back, things like that. So a couple examples. First one is there's a company called Blue River Technology. They were acquired by John Deere. And the use case that they were after was, you think about spraying for weeds in a field. You know, it traditionally is either a crop duster or a big sprayer that's indiscriminately spraying the whole field. And then you have Roundup resistant hybrid corn, you know, that can resist it. So what they did, they basically took and created a device that they can pull behind a tractor that's uses computer vision, robotic arms to identify specific weeds. Once the weeds are identified, it applies a specific dose of herbicide to it. And they were to build all the technology, kind of the product around this. And then they figured out they didn't have the data. They didn't have a bunch of photos that were tagged adequately to be able to create an algorithm. So they partnered with two universities, send a bunch of kids out into fields to collect information, tag these photos, and then they were able to create the algorithm. And then they used that. That's now kind of defensible intellectual property, that data set that they now have. And another example, since I am in Wisconsin, is the connected cow. And I would normally ask, you know, who grew up on a dairy farm, and I've yet to be in an event that didn't have somebody in a dairy farm. And I would ask, you know, how many times a day do you milk a cow? And it's always 2, except I had one guy that said his family did it 3 times. You know, what they find now with these automatic milking machines that essentially sense when a cow is ready to milk, that the optimal time is 4 times a day. And if you milk a cow 4 times a day, you can increase production by 30%. So trend 2, service business models. This is, you know, many companies are selling things, and they now create services on top of those things or create new services. So a couple examples. You've got sharing, you know, think about scooters, utilization. So engine manufacturers don't sell engines anymore. They sell basically cycle use. The bottom left is a company called Wash Laundry Systems. So think about the laundry facilities that you might find in apartments or dorms or hotels. They have 75,000 locations, and they created a connected appliance, and now they're able to do predictive maintenance. And this is a service tech that's getting alerts on something needs to get fixed on one of these. And they also are able to take it more to the consumer level. So sending out loyalty programs and coupons, and hey, go get your laundry, you got to pull your stuff out of the dryer, things like that. And then finally, the bottom right is really around, this is a Briggs and Stratton. They have a couple of lawnmower brands. And if you think about it, let's say you're a landscape contractor down in Florida and you're running 100 trucks. You have no idea what those landscaping crews are doing or where they're doing it. So Briggs created a GPS module that bolts on, tells whether it's on or off, where it is, made the module so they can put it on not just their lawnmowers, but others as well. And then they created a portal that a contractor can go into and be able to see what's happening. They created quoting capabilities using Google Maps to be able to generate auto quotes, and really built a whole ecosystem around it. And then we have image technology, the augmented reality. So think about the whole evolution of Pokemon Go overlaying images on your phone. So this is Hyundai came up with an owner's manual where you can point it to anything on your car and it will basically overlay, what is this thing? Okay, well, this is where the wiper fluid goes. This is where the radiator overflow goes. This is how you change a tire. Virtual reality, think Lord of the Rings, virtual worlds. And then finally, what's becoming really powerful is just computer vision and the ability for computers to recognize and kind of react to real-time images that are coming through. And then the final trend is really kind of this end-to-end processing. And the holy grail of appliance use cases, what's in my fridge? So if you think, this is a melee concept, but if you think about it, they have cameras in the fridge, it can recognize what's in there. Hey, your milk's getting low, sends an alert to your phone. Do you want to order it? And it goes to creates this automatic order. And then at some point, the grocery stores will be sending out their automatic delivery services. So all the components I just described are there today. And companies are now starting to piece more and more of those components together. So finally, let's say, what if we wanted to create a smart connected product? So we need a product, and that product, it's going to probably have some kind of board, some ability to connect. You might have to design an algorithm or two, so you build this product and then you say, okay, well, now are we almost there? It's, well, not quite. Now this product that you built is connected, it's software. So now you have all this whole ecosystem of systems around this product that you have to build and maintain. And you say, okay, well, now we get this in place, are we almost there? Well, not quite. So how do we know we're even working on the right problem in the first place? And that's really where, hopefully you have some sort of ideation process to narrow down your use cases, customer-centric approach to learn and experiment and figure out what use cases make the most sense. And then it's like, well, what if you want somebody to actually use this product? And so hopefully you have an agile process to go through your proof of concept, your MVP, put something into production. It's like, well, what if you want to use it in the real world? And when you launch something in the real world, when you go from selling a dumb lawnmower to selling a smart connected lawnmower, it's going to change every value stream in your company. And obviously IT, but your supply chain, where I take my lawnmower to get serviced, they're still using paper tickets. And so that's going to have to change. Customer service will have to retool. They're going to have to, teach you how to handle, phone apps potentially. Marketing, sales, redesign, legal, regulatory. And then the afterthought in many cases, security. But a few years ago, a denial of service attack was launched on the internet, basically by hacking into, hundreds of thousands of smart light bulbs with generic passwords. But it's important because the real world rewards those who build new business models, extend brands, create new channels, find new markets, redesign customer experiences, and reinvent business processes. So easy to say, hard to do, but worth doing it when you can do it. And then finally, and I'm not going to go through this in any detail, But if you think about what I just walked through and you look at what does it look like? It's really, the approach, you've got the upfront piece of defining the opportunity. You've kind of got this middle layer where it's creating the solution, coming up with the various IoT layers, your hardware, firmware, your transport layer, your application layer, and then generating value. That's more of the rolling it out into the real world. How do you handle real-time IoT data, retool customer service, integrated into your legacy systems? So if you're interested in getting into this piece more, kind of how do you do this in the real world, we have another session, as I mentioned earlier. It's and James Grogan he's the head of IoT at i3 Product Development, will join me. And we have one session right after this, and then another session Saturday at 12:30. So if anybody has an interest in that, there we're going to have people talking and bringing up their own use cases, and it's just more of an interactive discussion. So that's the wrap up. I went pretty fast. There's a couple minutes here at the end if anybody has a question. I always end my slides with do something, do anything, because you really just can't take a wait and see approach. You can't spend all your time planning. In a lot of cases, you just got to get in and start trying stuff because the world is moving too fast.
Great. Thank you, Brent. What a great topic. The thing that was coming to mind when you were talking about the ways that the business models may change around the product that we're enabling with smart products and the Internet of Things. The companies are rewarded by innovation, but product innovation is just one piece. Service innovation, customer service, how we connect with customers, and business model innovation is actually one of the ways that companies really get rewarded with growth. So enabled in many cases by going from a standard product to a smart product. Very cool. I would like to be able to open it up for the last few minutes that we have to anyone that has any questions. If you would like to put something into the chat, if there's a question for Brent, be able to get that answered, please do so now. I see that there is some chat in here. There's a link that was put in here from Justin on service design. So please check out the chat. There's some additional information being provided out there right now. So, Todd saying very cool stuff. Some great examples. Yes, I agree. There were some really good examples in your presentation. Anyone have any questions before we wrap things up? Oh, there's a Q&A. Second. Patrick, any suggestions to people who are trying to monetize IoT?
Yeah, I mean that's a whole other topic, and it gets into that business model innovation. And a lot of if you think about how do you monetize IoT, think about an appliance. Part of it is it being at a price point where it's worth, if you sell something really cheap, if you're going to put an application on top of it and sell it, may not make sense, because then we have to support this application for 7 years. It doesn't make sense. The one thing I'll talk about is this concept of hidden revenue. And I know a couple of companies where you look at their business model and you say that model, it just doesn't make any sense, but in reality, their business model is designed to generate data. Yes, Google, Facebook did a bunch of that, but there's local Wisconsin companies that are doing this, that are really collecting a bunch of data and giving things away for free and taking that data and really getting insights. One of them is getting insights to invest. Another is getting insights to basically be able to, kind of make their business more profitable, if you will. So those are, I know, Patrick, when you asked about monetization, I thought of data monetization, because that's the piece really where a lot of it comes in. It's not so much the value you're giving to your customer or your consumer. It's what's the data worth to you. And many companies, when we run a business case, that's the thing that justifies the project, not so much what it's going to do for the end customer.
Great. Any final questions from anyone? All right. Well, we're at our time. I want to thank Brent for a great topic. There's obviously a great deal of depth of knowledge that Brent's able to bring to this group. If you're interested in hearing more about this topic and some real world applications, as Brent mentioned, there is a small group discussion going on next with Brent and with James Grogan, who is a director of IoT at I3. Brent, is that correct, Brent?
Yep, I3 product development. Yep, exactly.
Correct. So if anyone's interested in joining that next session, please do so. And that same session is going on tomorrow as well. So again, thank you for everyone for joining. And Brent, thanks for a great presentation today. Appreciate it.
All right, great. Everyone have a good weekend.